Hi everyone. I hope you all are doing great today. So it's almost weekend. So okay, let's just wait few more minutes. Till then, let's do have a quick chit chat in the chat box. So let me know in the comment section how all you are spending your weekend. It's weekend and some of you are doing binge watching Netflix or some are upgrading your skills. So just let me know in the comment section how you are spending your weekend. You're planning to spend your weekend. Are you binge watching Netflix or binge eating or upgrading your skills through any course? So just let me in the comment section what all you are planning to do. And also tell your friends to join this amazing and interactive webinar with Ribhav Pahuja to upgrade and upscale your knowledge. Okay, let us just wait few more minutes. Okay, I hope you all are doing great. And I am Mishika Khandelwal from Geeks for Geeks and your host for today. And today with us, we have Ribhav Pahuja, who will be your mentor in this course. Yeah. Okay. So Tradip Kumar Roy said, practicing in lead code. Great. Okay. Tracking food. Okay. Great. So now it's time to welcome Ribhav Pahuja. Yeah. Hey, hi Ribhav.
Hi Michika, hi everyone.
Okay. So hi Ribhav, how are you?
I'm good. How about you?
I'm also good. So, Ribhav, so just start with a quick introduction of yourself, like before we move ahead, and I'll pass over this whole webinar to you. So, just give a quick introduction of yourself so that our audience will, know more about you and about the course, and what are the topics and what are the things we are going to cover in this particular webinar.
Sure. So, as you all know, my name is Ribhav, and I've been working as a backend developer at Sprinkler for almost 2 years now. So, I got promoted at Sprinkler to a senior product engineer, right? So, it's been almost 2 years since I have this experience in this industry, and so my key areas include BSA and algorithms, and like I'm more interested towards the backend stuff. So in this webinar today, we'll be covering hash maps, right? And we'll be going through the internal workings of the hash map, and we'll be covering end to end everything around the hash maps. Yeah.
Yeah. Okay, great, great, Rubhav. And guys, I have a surprise for you at the end of the webinar. So be with us at the end of the webinar. Don't go anywhere. Don't skip this webinar because this is going to be so informational and informative so that you'll add a knowledge and upgrade your skills through this webinar. And also at the end of this webinar, I'm gonna telling you what surprise I have for you guys. So Rubhav, over to you.
Sure. So I'll just share my screen, and let's start with the webinar, right?
Yeah. Over to you, Ribhav. Okay.
Just a second. I think it's taking time in sharing my screen. Yeah. So I hope my screen is visible. Can you guys let me know in the comments if it is visible or not? Just ping a yes in the comments in case my screen is visible. Sure. Thank you. So, guys, today we'll be going through hashing, right? So, I'll be explaining what is hashing, what are hash maps, how do we implement hash maps, and what are the key tricks and tips to know if a question belongs to a hash map, and how do we identify if a question belongs to hash maps, right? So, starting with the basics, first of all, let me explain what basically a hash map is and on what principles does it exactly work, right? So, first of all, let's understand hashing. So, what is hashing, right? So, basically, to explain it, hashing is nothing but it is a technique wherein we can use to basically get an index of an array corresponding to a string or any class for that matter, right? So let's say we have indexes in an array, right? So in order to tell that where does a let's say we have this array. So let me explain it with an example. So let's say this is one, this is two, this is three, this is four, this is five, and the indexes, as we all know, start with zero, one, two, three, and four, right? So to explain it, right? So in case I need to access the zeroth element of the array and the array name is ARR, so what I do is I do ARR zero, right? So so this only works with integer indexes, right? So let's say I need to store something of the form that I need array at, let's say, ABC. So I need to somehow map this ABC to a particular integer so that I am able to access, the index of ABC, right? So this is wherein hash maps come into play, right? So to explain it, so let me first explain what is hashing. So hash is basically a function. It is, let's say, a magical function which takes in a value, right? And it gives me an integer value corresponding to that, so that it is easier for me to access the integer array. As far as the syntax of the languages go, right? So this always needs to be an integer, right? So I'll be needing something such that the hash of that particular key gives me an integer. So that is what exactly hashing function is, right? So one thing I'll always have to keep in mind, right, that if I say, let's say, hash of ABC, then it should always give me the same particular value. Let's say if it gives me 154, right? So it's 154, right? So it should always give me 154, no matter what how I calculated or when I calculated, right? So one key feature that comes off hash here is that hash function always gives me the same value for a particular key, right? Second particular feature of a hash function that comes into play is I cannot decipher the key from its particular hash value, right? So let's say hash of ABC was 154. I cannot say that if hash of a particular value was 154, then its key was ABC. It can be anything else, right? So this is where we can say something exists, which is hash collision, right? So this is a particularly rare case wherein, let's say, two keys, let's suppose ABC and DEF, for example, they both give us the same hash value. So let's say they both give us 154. Then we obviously cannot say if the key was 150 ABC or it was a DEF, right? So we cannot tell from the hash value about the key of the hash function, right? So this is something that is all about the hashing. So this is hashing techniques, right? So these are hashing techniques. Now, how does it come into play during hash maps? So as I said, that for hash maps, what we have is, for integer arrays, we have index as integers. So I need to calculate an integer based on ABC, right? I need to calculate the hash of ABC. So hash of ABC, let's say, gives me zero, right? So I'll place the value corresponding to ABC at index of zero, right? So this is something that we have, right? So let's first get through the syntax of hash maps in Java. Then I'll explain further about hash maps, right? So let me just share my IDE screen. Uh, yeah, yeah. I hope my screen is visible, right? Just give me a second. Yeah. So so this is basically the implementation of a hash map, right? And what we do is, basically a hash map has three major functions, right? So the first one being the get. So uh, So a hash map basically, let me just explain it to you. So a hash map basically has three functions, which are get. These are the major functions: get, put, size, right? So also a hash map is basically something in which we store the values as key comma value, right? So it is something that is similar to an array, right? But since in array I cannot have, let's say, string indexes, so we store it in the form of a key comma value, right? So we can have something of the sort, let's say a corresponds to 0, b corresponds to 1, something of that sort, right? So it is basically a key value store, right? So yeah, and let's say b corresponds to 0. So in order to add these to a hash map, what I'll have to do is I'll have to like first declare a hash map, right? Of here we are using a hash map of string comma integer. So this will be my map, and what I do is I do a new hash map. So as you might be seeing, these are something that are known as generics in hash maps in Java basically. So I can declare any class here for that matter. It can be an integer, it can be a string, it can be any class that basically extends object in Java, right? And then what I do is in order to save these value a comma 1, right? I'll have to do map dot put a comma 1. And similarly for b as well, what I'll do is map dot put b comma 1, right? Yes. So map dot put b comma 1. Now one thing that you will notice, right, is basically a hash map can have same values, right? But one key area of hash map is that it can only have one value corresponding, one key corresponding to it. So if I do again map dot put a comma 2, then it will replace the value present in a corresponding to 2, and this will be overwritten, right? So if this is done and I print the map, it will give me b comma 1 and a comma 2. One more thing that we need to keep in mind is if I do if this is the case, then hash maps do not maintain the order of the keys in which they were added, right? So they do not keep the order. So it might be the case when I print this hash map, it might give me a comma 2 and then it might give me b comma 1. But the value of a will always be 2 since it was overwritten during this function, right? So any questions that you have for me so far? How to calculate hash? Yeah, we'll be going through this. Any other questions? I'll be explaining how to calculate hash and the internal working of the hash map as well. Okay, so I'll take that as a no, and we'll just proceed with the working of the hash map, right? So this was basically the syntax of the hash map, and let's say I need to get the value from the hash map. All I need to do is map.get a, right? So this will give me 2, right? And let's say in case that that key did not exist, so let's say I did map.get c, right? So in this case what we'll be doing is that it will be giving me a null, right? So this will give me null essentially. So this is these are some places which we have to like take into consideration while writing the code. That so map.get c gives me null, so it leads to null pointer errors in, let's say, so I do map.get c and I do some other operation dot, let's say, let's say I added to 2, so that might give me a null pointer exception, right? So that is something to be kept in mind, right? So yeah, so that is it. Now how do we implement hash maps? So we basically have two techniques. One is open addressing and the other is separate chaining. So let me just share my screen from the notepad, and let me just explain it to you. uh, Give me a second. Yeah. So the techniques that we use to calculate the where, so essentially, let's say we have this array list, right? And I need to place something corresponding to A, something corresponding to B, and something corresponding to C, right? So in that case, let's say I need to place something A, and this will be the key, and the value is, let's say, 1, right? So essentially, I need to place this in this array list, right? Array list or an array, that doesn't matter. But I need to place it here, right? So how do I calculate where this key A will go? So what I'll be doing is I'll be calculating the hash, right? Hash of A. Now this hash might come out to be a value greater than the size of the array list. So let's say this comes out as 7, right? And the size of the array list is 5. So what I'll do is I'll essentially mod it with the size of the array list, right? So that gives me a 2, right? So I'll place it on the just a second. I'll place it on the second index, right? Yeah, I'll place it. So I'll place it here. 0, 1, 2, 3, 4. So I'll place the hash node with the value 1, right? Now, so let's say I also want to place a B, right? And the hash value of B comes out to be 12, right? So this I'll again mod 5, right? Because 5 is the size of the array, right? And this again comes out to be 2. So now this leads to a collision as to I'll have to place A here as well and B here as well. So we have two techniques to cover this situation. The first one being open addressing, right? Open addressing, and the second one being separate chaining, right? So in open addressing, what we do is we basically check if the next node. So in open addressing as well, there are three techniques, right? Let me just write them down. So open addressing has three techniques. So the first one is linear probing. This is quadratic probing, and this is double hashing. Right. So what we do is in linear probing, what we do is we basically check if the next value corresponding. I got B as 2, right? So the second index is already filled. So what I'll check is if the third index is empty, right? In case it is empty, what we do is we place that corresponding that key comma value here, right? So this is linear probing, right? So I'll place B comma, let's say 2 here, right? So let's say I again get hash of C as 2, right? So in this case, I'll have to again check if 3 is filled or not, and then if 4 is filled or not. And if 4 was also filled, I'll go back again to 0, right? So this is linear probing. And in quadratic probing, what we have is, to explain linear probing, what we do is we check if hash of x plus 1 mod the size is empty or not. In case it is filled, then we check for hash of x comma x plus 2, and so on and so forth. So in quadratic probing, what we'll do is we'll check for hash of x plus 1 into 1. In case that is filled, we check for hash of x plus 2 into 2, and then hash of x plus 3 into 3. So as you can see, this is a quadratic equation, a square, right? X square. So we do y square for that matter, since we are using x here. So we do y square plus hash of x. So in that case, so we check, and yes, obviously this is mod size, right? So we in case this was not, this was filled, so we'll check 2 plus 1, then we'll check 2 plus 2 into 2, that is 2 plus 4, so that becomes 6 mod 5. So 1, we'll check this index. And after that, in case this was also filled, then we'll check 2 plus 9, 11 mod 5, that is again 1. So we'll check this, then 16 plus 2, 18 mod 5, then 3. So so on and so forth, right? In double hashing, what we do is we take a function, we take two hash functions, right? So hash 1x plus 1 into hash 2x. So this is something that we'll calculate. In case this is as well, this is filled as well, then we'll calculate hash 1x plus 2 into hash 2x and so on and so forth. So that is why it is known as double hashing, because we are having two hash functions and we are calculating the next index based on that particular hash function, right? So any questions for me so far? Any questions for me? Vignesh is asking, does a hash map maintain order? No, no, Vignesh, it does not maintain order. For that, we have linked hash maps in Java, but maybe we can explore it further during our sessions. Which probing is used in Java HashMap? So essentially, Java HashMap, this implementation I'm talking about was before Java 7, right? And currently, Java HashMaps use binary trees to implement the HashMaps internally. So that is something that we kept for the course, that we'll be exploring it further. How does Java 8 implement HashMaps? They were asking hashes have one to one relationships. Not exactly, Dave. So let's say hash of let me just explain it. So let's say hash of 1 can be 150 and hash of 2 can be 150 as well, right? So 1 to many is uh, so hash of 1 can be 150, hash of 2 can be 150. So as you can see, so this can be many to 1, right? Many to many, in fact. No, sorry. Yeah, many to 1. So hash of 1 will always give me the same value, right? But two keys can have the same hash values, right? So that becomes a many to 1 relationship, right? Any other questions that you have for me? Okay, I'll take that as a no. Got it. So the uh, these are the collision handling techniques that we have for hashes, right? Apart from that, someone asked, which I said that I'll be taking it further. Yeah, so someone asked how to print full map elements with loop or anything else. Got it. So let me just explain it with the code itself. So to So, so there's a function in Hashmaps which gives me all the keys that are present in the hash map, right? So integer I. So we had a string hash map, right? str colon map dot key set. So as you can see, this is the so str would be the key and system dot out dot println key and system dot out dot println map.getKey. So this is the syntax for printing all the hash map values and keys. One more function that we have is map.entrySet, right? So uh, this will essentially become entry of string comma integer and key.getKey and key.getValue. Right. Is hash map similar to a dictionary in Python? Yes. Oh, sorry, coding screen not shared. I'll just share it. Give me a second. Yeah. So this is something, right? So essentially, this is the map.keyset function, which essentially gives me all the keys which are present in the hash map, right? So this will essentially give me a comma b, right? And then I iterate over all the keys and I print the key and I print the map.get key as well. So that gives me a and then it gives me the corresponding value, that is 2, and then it gives me b and the corresponding value, that is 1. right? The other function that we have is map.entrySet, right? It gives me a basically an entry object which contains both the key as well as the value. So so this will be str.key and get key and str.get value. Yeah, so this is a function that we have to in order to print the elements. I did share the ID screen. It is visible now, right? Ashish, is it visible to you? Yeah, we can have strings as the key and strings as the value as well. Yeah, Kuldeep, we can give you the code and okay. Any other questions? Difference between entry and hash map. So essentially, as I told, right, that entry is basically so this is a function of the hash map, right? So I have this map object, the hash map object, and the entry set uh, will give me uh, values of entry of string comma integer, right? So this is something that we have. Someone was asking, can we have string as the value? We definitely can have string as the value. We can have any class as the value, any class as a key. Difference between map and set. Very good question, Kuldeep. What is a map? Is basically it has a key and a corresponding value. Whereas a hash set, what it has is, let's say we have this hash set, right? So it only contains the keys. It does not contain the values, right? So we can have a hash set of a string str set equal to new hash set. So as you can see, it just takes in one parameter, right? And we can only store strings corresponding to that. So let's say we add str.set abc. So it can only contain a key and not a corresponding value to that key. Could you explain about thread safety? Yeah. So, Ashish, hash maps are not thread safe, right? So, essentially, when we let's say some thread is accessing and putting something into the hash map, and after that, some thread is let's say pulling from that hash map, then it does not guarantee that will it give the same value or not. Right? Any other questions? Could you change your video set to the right? Mishika, can we do that, please? Someone is asking to change the video side to the right so that the ID is visible. Yeah, thank you, Vishnu. Uh, Deepak, what do you want to know about the performance? So, in case you are asking about the insertion, deletion, and uh, searching of hash maps, so essentially it basically depends on what exactly are we on our hash function, right? So let's say we want to insert something. So I'll just go through the internal working of the hash map. I think we'll explain that better there. Any other questions from till now? What we've covered till now? Can the keys be mutable? So essentially, what I explained was if I do map dot put a comma 1 and I do map dot put a comma 2, right? Then the next statement map dot put a comma 2 overwrites it, right? In case you are asking that if I can do this or not. So in case, let's say I do string str equal to map dot key set, right? So I am exactly not sure what you are trying to ask. Okay. So let's go through the internal working of the hash map. So before that, I'll have to explain a certain node concepts, right? So let me just share my screen of Notepad and let me explain more concepts. Yeah. So one thing that we need to know is the load factor of the hash map, right? So yeah. So we have something called the load factor of the hash map, and we also have something called rehash. Right. So now what is load factor? So load factor is not a term that is related essentially to hash maps. It basically is a generic term which basically denotes that how many keys do we have. So no, not exactly keys. How many how do I explain it? Yeah. So how many, just give me a second. Yeah. So how many indexes which we have which are already, you know, covered, which already have keys in them, right? And so load factor is basically the number of indexes that have keys in them divided by the total size of the hash, right? So essentially, we need to keep this ratio always less than 0.75. So this is a threshold that Java internally used to follow before Java 7, right? So we keep this ratio less than 0.75, and we'll also be keeping it less than zero point 0.7 in our code. Now, what is rehashing, right? So there might come a certain point wherein the number of indexes that have the keys might become greater than 0.75 into size, right? So in that case, what we do is we basically increase the size of our array list in which we are storing the hash map to twice the size. So essentially, then that will the load factor becomes less than 0.75. And in that case, since we used to calculate the hash mod size of the array list, then what we'll have to do is we'll have to calculate the hashes again and place the corresponding keys at the right position. So let me just explain it with an example, right? So let's say we had this array list, right? So uh, 0, 1, 2, 3, right? I got the hash of ABC as, let's say, 5, then mod 3 becomes 2, sorry, mod 4 becomes 1. So this is 1. Then I'll place 5 exactly here, right? So the current load factor is 1 by 4. Right? Then let's say I calculate the hash of DEF. It comes out to be, let's say, 6. Mod 4 becomes 2. And I place DEF along with, yeah. So DEF here, and the hash was 6. So this is essentially not required. We placed ABC here, we placed DEF here. Now the load factor becomes 2 by 4. That is the number of occupied indexes divided by the total size of the array list, right? And let's say we had hash of JKL, and that came out to be 7. We did mod 4. So this gives us 3. So we'll place JKL here at the third position, right? And now the load factor becomes 3 by 4, right? So essentially now is the time that we need to rehash our hash map, right? So essentially what we'll do is we'll increase the size of the array to twice. So 8 elements in the array, 4, 5, 6, 7, 8, right? So 0, 1, 2, 3. So we increase the size, and now so hash of ABC was 5. So 5 mod 7 is essentially again 5 only. So we'll place ABC at the fifth index. Then DEF was 6, right? So so this 6 mod 8 becomes 6 again, right? So we place DEF here itself. So DEF. Then 7 mod 8. So 8 is the size of the array, right? So JKL will be placed here. So as you can see, the positions of the keys changed, right? So earlier it was at position 1, 2, 3. Now it came out to be 5, 6, 7, right? So this is what we call rehashing, right? And load factor is basically the number of occupied spaces divided by the total space, right? So any questions so far from this? Yeah, I'll just code it right away. Yeah, Deepak will share the code after the class. Any other questions that you guys have for me before we dive into coding? Okay, cool. I'll take that as well. So let me just share my IDE screen. Yeah. So essentially, as we saw, right, that map is supposed to be a uh, generic class, right? So essentially, while we'll first make a map node, right, which contains a key, k comma v. So k denotes the key, the type of key. So essentially, we could have it like this as well. So we could have it of the form, let's say integer. Uh, so essentially, we took it string. So let's call it string only. String key and integer value, right? But to for the map node to support uh, for the map node to support different classes, what we have is we have defined a generic object, generic class. So a key can be of any type of k and v can be of any type of v, right? So essentially any class that inherits the object class in Java can be present in the map node itself, right? So uh, now let's go through the map and the functions that we have, right? So as I said, right, that this we have an array list of map nodes, right? So and we also have the size. So this is basically the array that we are trying to store. As I was, let me just share my entire screen. Uh, yeah, I hope my screen is visible, right? Yeah. So essentially, what we are trying to store in buckets is basically this very. So one thing that I want you guys to know is we'll be implementing the separate chaining separate chaining algorithm for hash maps, right? So in separate chaining, what we do is, let's say the hash of two values comes out to be two, right? Then what we do is instead of like checking the next and the next to the next, like instead of doing linear probing and quadratic probing and all, what we do is we maintain a linked list here, right? So let's say uh, that it came out to be the hash function of two values of ABC came out to be 2 and the hash function of DEF also came out to be 2, right? Then what we'll be doing is we'll be simply putting in ABC here and DEF also came out to be 2. Then we'll also be putting DEF in this particular linked list only, and this currently points to null. So essentially, if another key comes in which has the hash value as 2, then we'll be putting it here in the last and we'll be making it the last node of the linked list, right? Any questions from separate chaining? Then we go on to implement it. Okay, cool. So let's just go over separate chaining once. So this essentially buckets is the same as our array list that we were trying to store here. So this is what we call the buckets array list, right? So initially what we do is we can either take in the internal the exact capacity of the buckets, or maybe we can initialize it to a size of 3, right? So whenever we, let's say, declare a map object, we do buckets equal to new array list so that it is easier for us to initialize the buckets object with the size of 3, right? So what I do is I do buckets dot add null, right? So essentially this is basically nothing but these all are pointing to null objects. This is null, this is null, this is null, right? So this is the size of this is 3, so this doesn't matter, right? And all these are null objects here, right? So these are basically three linked lists with null as their head, right? Now, let's say we want to put something into the hash map, right? So what essentially goes into our mind is we'll have to first create a map node, right? So something wherein I can store my linked list node, right? So let's say I get ABC and corresponding to that I need to put in 2, right? So this is what that's something that I'll be doing. I'll be creating a new map node object with the key ABC and the value 2, and I'll be placing it at that particular position wherein my hash of ABC comes out, right? So to code it here, what I'll be doing is I'll be basically like, let's say I get the bucket index. So how do I get the bucket index? By calculating the hash of the key, right? So I had the string ABC, and to calculate the hash, we have something called the hash code as the function, which is internally implemented in Java, right? So what we do is we calculate the hash of string ABC, and then what we do is we mod it with the size of buckets, right? So this basically gives me the index at which we'll be placing the string ABC, right? Now once we get that index, what I need to check is that do I have some elements here or not. In case I do, I'll have to place my ABC at the end of the linked list, right? In case I do not have any elements, I can just create a new linked list and I can place it there, right? So essentially head equal to buckets dot get. So this is basically what we are doing. We are checking if there is some linked list present here or not, right? So what we do is we iterate over this linked list, right? In case there was nothing present, then head becomes null, temp becomes also null, and we simply return null. So this is get function, right? So in the put function, head equal to buckets dot get bucket index, we make a new node, we initialize the key as we'll say here ABC and the value as 2, right? So if our head was null, we simply do buckets dot set bucket index comma new node, right? So essentially what we did here was, since this was null initially, what we'll do is we'll place ABC comma 2 here, right? And the next of this points to null, right? So after this, let's say DEF comes in, its hash also came out to be 2, right? So what I'll be doing is I'll be iterating over this linked list, right? I'll be checking if DEF exists in this linked list or not, right? In case it does not exist, I'll go to the end and I'll append DEF comma 3 at the end of the linked list, right? So this is what we are doing. We are iterating over the linked list. So while temp is not equal to null, and we check if there exists a key DEF in that particular linked list. In case it does, we simply overwrite the value. In case it does not, what we do is we simply add it to the end, right? So again, buckets dot set. So essentially, buckets here we are calculating the load factor. We check if it is greater than 0.75. Then we do rehash, as I told you guys. So essentially, in rehash, what we are doing is we are doing nothing, but we are increasing the size of the buckets, and we are iterating over all the linked lists and placing them on the right positions, right? So we are essentially doing put current dot key comma current dot value and current equal to current dot next, right? So essentially, what we have is in separate chaining, to insert an element, what the time complexity becomes is it. So let's say my maximum linked list size was n, right? So it becomes big O of n in case of separate chaining, right? So in case it was n, so on an average, since we do not have as much collisions, right? So on an average, it becomes big O of 1. So what we assume is the linked list sizes at most, let's say 2 or 3, right? So for each hash, we have 2 or 3, right? 2 or 3 linked list size, right? So essentially, to calculate the insertion, all we have to do is we have to calculate the hash function and place it at that corresponding linked list size, right? So essentially, that becomes O of 1. Obviously, searching also becomes O of 1 because we need to search only in that particular linked list corresponding to the hash of the key. And also deletion also becomes essentially O of 1 because what we are doing is we are going to iterate over the linked list and doing nothing but simply deleting that element. So deletion in linked list is going to that particular element and deleting. And since we have the size as at most 2 to 3 elements in that linked list, so this is basically O1. Any questions that you guys have for me? How to create this array of linked list? Okay. So essentially, ask this question. Yes. Satvik, yeah. So Satvik, what we are doing is basically, let's say I have this array list of map nodes, right? So essentially, if I just have a head of the linked list and my head points to the next element and that next element points to the next of the next element. So essentially, all I need to do is I need to just maintain a map node array list, right? So this map node obviously contains the next element and then that can be storing the rest of the linked list, right? If you get that, if you're familiar with linked list. In case you are not, we'll be going through that in the course as well. Any other questions that you guys have for me? Okay, I'll take that as a no. Uh, I think that brings us to the end of the webinar. We have gone through pretty much about how exactly we'll be going through the internal workings of the stuff, and obviously we'll be going through a lot of, a lot of the implementation and the workings. Not only that, we'll also be going through the use cases. We'll be going through a lot of questions that come up. When and how do you implement override exactly the get hash code function? Right. So the get hash code function is basically something that is implemented inside the objects class only, right, Ashish? So in order for us to have something, yeah. So this is something that I missed. Good question, Ashish. So essentially, if we need to add something to the hash map of the Java class, right? We need to have the equals as well as the hash function overridden inside our class, right? So string, integer, these already have that. But in case we are writing our own class, we need to have them implemented in the hash in our class. Yeah, Mishka, I think we are done with the webinar from my side.
Okay, thank you so much, Ribhav. So it was a quite interesting webinar. Even I get to learn a lot of things, and I have understood a bit concept of hash mapping. Just don't ask me questions. What is hash mapping? But yeah, I do understand what a bit about of hash mapping and the concept of hash mapping. So yeah, it was a quite
Thank you.
interactive and informative webinar. So thank you so much for this amazing webinar. So
Thank you.
everyone, I hope you guys enjoyed this webinar and learned a lot of things. So if you want to know more about the hash mapping and the DSA, and you want to go deep dive into this course, so just go register to this course, which is especially for the working professionals to enhance your skills. You if you are working with a company, or enhance or upgrade your skills, so this course is just for you. And if you want to start with the basics, and you are in the intermediate level and go into the upgraded version. So Ribba will be clearing all your doubt in the live course. Go register to this course and avail the exciting offer, the surprise which I was talking about in the initial of this webinar. So if you register for this course just now, you will get 1500 off on this course, and also you'll get the complimentary access to the Google test series as well. So what are you waiting for? Go register yourself for this course, where Ribber will be your mentor and teaching you and clearing all the doubts of yours of DSA. And if you are working in any company and you are looking to go in a top notch firm or any other company you are seeking, so this course is just for you. So yeah, thank you so much, Ribhav, for this interactive session. Thank you so much.
Thank you, Mishika.
I hope you and everyone has enjoyed this session. Yeah.
Definitely. Yes.
Yeah. Thank you so much, Ribhav.
Thank you, Mishika. Bye bye.
Bye. So yeah, and also guys, we also have a form as well. If you have any queries regarding this course, you can just put your query in that particular form, and we'll resolve every query of yours. And go just check out this course. The link is in the description box. Go check out, register for yourself, and first come first serve. Go check out the course and see the every details of this course and register yourself so that you can avail the 15% offer. 1500 off on this particular course. And we have few more courses as well, whose link which we have added in the description. Go see the link and explore more. Thank you so much, everyone. It was great interacting with you all. And be with Geeks for Geeks for more interesting and informative webinars. Thank you so much, everyone. Also, to use this offer, avail this offer, you need to use the code upscale15, which we have added in the description as well. Use coupon code upscale15 to get 1500 discount on this particular course.